Hey guys, welcome to our first online class, I guess. We are going to be doing chapter 4B today. So, we are beginning our section of the class on our money problems. So, we will be talking about how to calculate interest. And in this section, we're just going to be doing simple interest, compounded interest, and then interest that compounds multiple times a year. And then our next section will be loan payments, savings plans, stuff like that over the rest of the chapter. But to begin, we will start off with some definitions that y'all will need to know. The first definition is going to be principal. So the definition of principal is, in financial formulas, the balance upon which interest is paid. So if you are pulling out a loan, it is going to be interest calculated on your loan. If you are investing, it'll be interest calculated on your original investment, stuff like that. The next definition is going to be simple interest. So the definition of simple interest is interest paid only on the original principal and not any interest added at later dates. So we just continue to calculate interest on our original amount, our original principal. Next is compound interest. Compound interest is interest paid on both the original principal and on all interest that has been added to the original principal. So as we'll see in these next examples, the compound interest is going to grow a lot faster than the simple interest. And we'll look at that here in this first example, simple versus compound interest. So we will suppose your principal investment is $1,000. You plan to receive 5% interest gain on every year, and you're investing for five years. So first we are going to calculate the simple interest. What is important to note is that whenever we are calculating interest or any sort of money problems where we're given a rate, we always convert that we always convert that rate into a decimal. We never use the whole numbered percent. So instead of using 5%, we're going to convert to a decimal to 0.05. Now I'm going to make y'all this real pretty table so that it's nice and organized for you guys, since I can't show y'all it handwritten. So let me get this formed really fast. I think this should do it here. Let's see how this looks. Beautiful. All right. So the first year, year principal, interest, and total owed is the title of our table. Year number 1, our principal is $1,000. After 1 year, we have accumulated, I need to make that a dot and not a comma. Sorry about that. We have accumulated interest of 5% upon our $1,000 principal. So that brings us to $1,000 times 0.05, and your calculator is $50. So our total owed, we have to add the interest on top of the principal, so that gives us 1,000 plus 50 equals 1,050. So after 1 year with our principal investment at $1,000, our total owed is going to be $1,000 plus the $50 of interest, which is $1,050. After year number 2, we kind of do the same thing for year number 2, where we again calculate that exact interest rate on this principal, the interest rate being 0.05 multiplied by that $1,000 principal. It gets us again $50. But now for our total owed, we don't again owe $1,050 after 2 years. After 2 years, we owe the $1,050 plus the $50 from the second year of the interest, so we owe total $1,100. So even though our interest is going to be the same, our total owed is going to keep going up. So the longer we have this investment, the more we should gain, which is kind of the point of investments, right? If you want to try to fill the rest of this table on your own, go ahead and click pause and do that now for years 3, 4, and 5. If not, go ahead and stay with me. I'll explain the rest of it as well. Year number 3, we are going to do pretty much the same story as what we did for year number 2, where we do principal is $1,000, our interest is 0.05 multiplied by $1,000, which is $50. And again, for that total owed, we are adding the previous total owed with the interest. So the $1,100 that we owed from the 2 years added with the $50 is $1,150. I guess we don't owe. I think we're investing in this example. My bad. So we're gaining, not owing. So $1,100 was the gain from year 2. We add another $50 from interest, so now our total gain is $1,150. For year number 4, we do again the same thing. We still have our principal is $1,000. We still have our interest is $50, and our total owed, again, we're adding it on to how much we owed from year 3. So $1,150 plus $50 is $1,200. And finally, that gets us to year 5. Year 5, we are going to calculate interest one more time and add that interest back onto our total owed, which gets us to $1,200 plus $50 is $1,250. All right. Now this is what we have gained from the simple interest formula. So if we're investing, that means we invest $1,000, and whoever we invested it to now owes us $1,250. So it was a $250 gain for us. So it was a good investment. Next, we will do compound interest. Again, since the interest is 5%, we are going to convert that to a decimal and use 0.05. What's cool is in the beginning of compound interest, it does start off pretty much the same, where we have just the basic $1,000 with the $50 interest rate. So, here it is. So year 1, $1,000, interest is 5%, which gets us 0.05 times 1,000, which is $50. So our total owed is 1,000 plus 50, which is $1,050. What gets interesting about this is when we get into year number 2. So the difference between simple and compound interest, again, is that when we are doing compound interest, we are doing interest on the total owed. So every time we recalculate interest, we don't apply it to the principal, we actually apply it to the total owed. So for year number 2, we are going to calculate our interest on this total owed dude here, this boy. So 0.05 multiplied by 1050 is 52.5, which gets us 1050 plus 52.5 for total owed, since we still have that 1050 from the previous year, and now we're adding on again this new interest. So now we have 1102.50. We will continue to do the same thing for years 3, 4, and 5. If you want to try to fill the rest of this table on your own, I encourage you to do so. If you want to stay with me, fabulous. Let's get to it. So year number 3, we start with our total owed again as our principal. Our interest is going to be that amount multiplied by our rate, so 0.05, which gets us to 55.125 as our new interest. Then for this total owed column, we are going to add this interest 55.125 onto our total owed from last year. And then we round because we want it to be to the nearest cent. It doesn't make sense to owe 0.625 cents, so we rounded it to 0.63, where you get 1157.63 as your new total owed. Year 4 will again be the same strategy. We take our total owed, which was 1157.63, we multiply that by 0.05 to get 57.88. We then add that new interest onto our total owed from the previous year to get us back to a new total owed, which is 1215.51. And finally, long awaited, our year 5. Year 5, we take our, oops, I forgot a 1 there. There we go. Our year 5 is going to be the 1215.51 here from our total owed of the previous year, multiplying that by our interest rate, which is 0.05, gets us to 60.78. We then add 60.78 onto our owed from the previous year to get us that 1276.29. So hopefully now y'all can see that with the compound interest, it does grow faster than the simple interest. We will take a note of the difference in the two total owed columns. With the simple interest, it was 1250. With compound, it was 1276.29. So you can see that here we made less money than we did here. So about 26.29 less dollars. All right. Hopefully y'all got that and y'all understand the difference between the simple and the compound interest, how we're constantly compounding on the total owed here, while then the simple interest, we just kind of keep the same flat rate interest and add that on every year. So now what's really great is we can use formulas now that we understand. So the formula for simple interest gives us interest only. It gives us I for interest equals PRT, which is principal, rate, time. P for principal, R for rate, T for time. Our compound interest guy, that A stands for accumulated balance. Accumulated balance. What accumulated balance means is essentially the entire that either you owe or that you gained in an investment after all of your years of investing or owing in a loan. So if it's a loan and you have your loan for, 10 years or whatever, your accumulated balance would be how much you owe back from the loan, principal including interest. If it's an investment, that accumulated balance is going to be how much you've gained. So your principal investment plus the interest that you've earned would be your accumulated balance. So I guess if you're wondering how to spell that, I could write it here. It is accumulated balance. Okay. So we've deposited $5,000 in an account. We are going to gain 6% interest. Part 1. How much will be in the account after 5 years with simple interest? First, we are going to calculate the interest. We are going to use the simple interest formula. So we will have I equals 5,000. So I'm right here reading this to y'all. We'll calculate interest using simple interest formula. We have I equals 5,000 multiplied by 0.06 multiplied by 5. The reason we have the numbers in that order is because P stands for principal, and that's going to be our 5,000. R stands for rate, that's going to be our 6% interest, so 6% we change to 0.06. And then the T is time, so how long we invested was 5 years. So that's where that 5 comes from. For the interest, for the simple interest, all you do is just multiply these three numbers, you get 1,500. And it's important to note that the 1,500 is only the interest that you have gained. So on the principal. So to find the total that you owe, you need to add the principal, which is 5,000, plus the interest that you gained. So it's a total of $6,500, and that is the answer. So 6,500 is the answer to that problem. Part 2 says how much will be in the account after 5 years with compound interest. So compound interest, we can just plug straight into the formula because our formula is A equals, where A is the accumulated balance. So simple interest is really the only one that has those two steps where you have to find the interest and then add it back onto the principal. With the other formulas, it's usually in the form A equals, which means you can just plug all the numbers into the formula, put it in your calculator, and then you are done, which is fabulous. So with compound, we'll plug into the formula directly, and that will give us the accumulated balance. The numbers plug directly into the formula, so your principal is still 5,000. That goes here for the P. 1 plus, so it's going to be 1 plus 0.06 to the T, so to the 5. All right, so we have 5,000 multiplied by 1 plus 0.6 to the 5th, which should give us 66 91.13. So if you're wondering how we get these numbers, I will show you here on my little calculator. So if you do 1 plus 0.06, you get 1.06, you raise it to the 5th power, you get this ugly number, and then you multiply it by 5,000, and you get 6691.127. So we round up to 6691.13, and that's where we're getting that number. All right. Suppose you invest $1,500 in a savings bond that pays simple interest of 10% per year. How much would you have after 5 years? How much would you have after 5 years if it were compound interest? So first we'll do the simple interest. So with simple interest, we have that I equals 1,500 times 0.1 times 5, which is 750. So A, our accumulated balance, is going to be the 1,500 principal plus the 750 interest, which gets us a total of 2,250. So after 5 years with simple interest, we'll have $2,250. With compound interest, however, we plug it into our formula. 1,500 multiplied by 1 plus 0.01 to the 5th power. We get $2,415.77. So our accumulated balance is $2,415.77. Woo. So we get more with compound interest than we did with simple. All right. My final example. Suppose you invest $200 in a bank account after paying 3.5 interest compounded yearly. How much would you have after 50 years? What about 500? So in this problem, it's important to note that I did write the words compounded yearly. So that means we're using the compound interest formula, not the simple interest formula, because it would say with simple interest if that's what it wanted us to do. But it wants us to do compound interest. So after 50 years, we would have 200 times 1 plus 0.035 to the 50th power. That means our $200 would have grown to $1,116.99. However, if we just leave this alone for 500 whole years, we get some massive number. So after 500 years, we have 200 times 1 plus 0.035 to the 500 power. We get, all right, let's see if I can say this number, 5,904,795,918.57. Dang, that is quite a lot. All right, next page. Compound interest formula for interest paid in times per year. What this means is that your interest is not just being compounded one time per year. So what we've been assuming thus far is that we just deposit this money and at one point every year our interest is calculated like that. There are cases where your interest is calculated multiple times per year, every 3 months, every 6 months, every month. So this is the n times per year. So when you're looking at this formula, it's very important to understand what all the letters mean. So the A is the accumulated balance. We did talk about accumulated balance. That is kind of like your total, your principal plus your interest. The P is always going to stand for principal. APR is annual percentage rate as a decimal, because we always write percents as a decimal. Very, very important to do that or your number is going to be crazy large. So APR, annual percentage rate. N is the number of compounding periods per year. T is going to be the number of years. So here in our first example, we are going to deposit $5,000 into a bank account that pays an APR of 3% and compounds interest monthly. How much money will you have after 5 years? So what's important to note, let's see, what color do we want, guys? Orange? I like orange. So if it's compounded monthly, let's see what orange looks like. Oh, that's cute. If it's compounded monthly, that means n equals what, you guys? How many months are in a year? I hope you know. If it's compounded monthly, that means n equals 12. So 12 months in a year, that means we're compounding 12 times a year. Make sense? Awesome. So that means if we're filling in our formula, we have our, we don't know the A, that's what we're looking for, right? But our principal was 5,000 because that's how much we deposited. So it's 5,000 times, excuse me, 5,000 times 1 plus, our APR is going to be 3%, so we convert that to decimal to be 0.03, divided by the N, which we just talked about was 12. Close parentheses, and then our power is going to be N times T. Our N is 12 multiplied by our T, which is that 5 years. When you plug that into your calculator, you should get this number. If you are kind of concerned on how to plug that into a calculator, I'll go ahead and do that for y'all right now. So we have 0.03 divided by 12, right? We're adding 1. We're bringing that to the power of 60 because 12 times 5 is 60. And then we are multiplying that by $5,000, which gets us 5808.083. But since it's 0.83, the 3 tells us we can keep the 8. We don't have to round up, so that's why I left it at 58.08, since we always round to the nearest cent with the money problems. Alrighty. Oh, you know what, you guys? Look what I did. Step-by-step solution. Step-by-step solution for calculator problems. So if you're having calculator issues, please don't hesitate to reach out to me. The next example, suppose you deposit $3,000 in a bank account that pays an APR of 12.5% compounded quarterly. How much money will you have after 10 years? All right. Remember that compounded quarterly means we're compounding 4 times a year. I could make that orange again just so we're consistent in our coloring. All right, cool. Quarterly is 4 times a year. If you're having trouble, remember that. Just remember there's 4 quarters in a dollar. So anytime you see the word quarterly, know that that means 4 times per year. Plugging that into our formula, we're going to have $3,000 as our principal multiplied by, we look back up here, this formula, multiplied by 1 plus APR, which is 0.025, divided by N, which we found was 4, to the power of N times T. So 4 times 10, because our time here is 10 years. And that's equal to, once you put it in your calculator, $3,849.08. Make sure when you are doing this, you are watching this video here right now with me today, that you are trying to put this in your calculator and making sure that you get the same numbers that I am showing you. It is very important that you are able to plug this into a calculator. Thank you. All right, a new definition. Annual percentage here. Annual percentage yield is the annual percentage by which a balance increases in 1 year. There is a formula. Here is the formula. It is fabulous. APY equals absolute increase divided by starting principal. So if we want to find the annual percentage yield, we can take the previous example to kind of give us an example of how to find the annual percentage yield. So we take our absolute increase, which is the 3849.08, and we take our starting principal, which was the 3,000, and we plug that into our formula, and we get 3849.08 over 3,000 is 1.28, which gives us 128% increase per year. All right. Next. Continuous compounding. Continuous compounding is kind of interesting. It basically means you never stop compounding your interest. So there's no quarterly, monthly, daily, nothing like that. You are just constantly compounding this interest onto your principal amount. So our formula here is A equals P times E to the APR times T. Some of you
may recognize this from a previous algebra class. Some of you may not, which is fine, but it's also sometimes said PERT. So P times e to the RT, but it's the same idea. APR is annual percentage rate, so we're always just using the symbol APR instead of R because we're always having an annual percentage rate and not just a rate. So suppose you deposit $100 in an account with an APR of 8% and a continuous compounding. How much will you have after 10 years? So all we do is plug this straight into this formula. So we're looking for accumulated balance. Our principal is $100. We have e to the 0.08 because that is our rate as it says here in this problem. And then our time is going to be 10 years because that's what it says in the problem. So we get 100 times e to the 0.08 times 10 is approximately $222.55. So we gained $122.55 after 10 years. The next example. Suppose you put $1,500 into an investment with an APR of 5% and, that says and, oh my gosh, I have a typo. My worksheet, okay. Let's fix that, there we go. Oh, nope, wrong and. I'm gonna find it. There it is. And continuous compounding. How much will you have after 15 years? If instead you had invested with quarterly compounding, how much money would you have? All right. So first we'll find the continuous compounding. So continuous compounding, relatively straightforward. You just plug that straight into that boy up here, right into the boy here. That P is 1500, that APR is 0.05, that T is 15. We plug it in and we get $3,175.50. We are going to compare that with what we get if we would have used the other formula for quarterly compounding, which was, I can actually, here I'll scroll back up if y'all are getting confused. It's here, compound interest formula for interest paid in times per year. So we're using this formula again for quarterly compounding down here. So that's 1500 multiplied by 1 plus 0.05 divided by 4, all to the power of 4 times 15. You put that into your calculator and you should get 3,160.77. Again, it's really important that y'all are plugging all of this stuff into your calculators so that you know that you are doing your calculations correctly. If you'd like to see me plug this into the calculator, I'll go ahead and do that for y'all right now so y'all can see how I plug it in just so you can make sure you're doing it correctly. I will do the quarterly. So we have, again, order of operations, we start inside the parentheses. We have addition and division, so we have to start with division. So that's 0.05 divided by 4. We can then add the 1. We can then take it to the power of 4 times 15, which is 60. And then multiply it by 1,500. So yeah, there it is. 3,160.77. We cut here because we don't want the rest of this. We only want the nearest cent, which is going to be 0.77. Hopefully that made sense. I'm going to keep moving on. So the last page of our worksheet today are all examples. I'll go ahead and go through the first one with y'all, and then I really want y'all to try the next two by yourselves. I'm just going to go ahead and trust that you're going to do that because that's what we got to do here today. So the first example says, how much would you need to deposit into an account today to have $6,000 in 8 years? Suppose quarterly compounding in an APR of 4%. So what's very important is when we're reading this problem, we notice what our letters are. So we have accumulated balance, we have A, P, APR, and T. So our APR is 4%, our time is 8 years, but that $6,000, it's actually our accumulated balance. So if our end goal, I'll read this to y'all. Here it is important to note what we are looking for. Our end goal is $6,000, which means A equals $6,000. We are also given that it's quarterly compounding, the time is 8 years, and a rate of 4%. Thus, we're looking for P, the principal amount. So that changes our formula a little bit. So instead of having an A equals, we're going to have 6,000 equals, because we're not looking for A anymore. We're looking for principal amount. We're looking for what we need to initially invest today in order to gain this $6,000 that we apparently need for some reason. So solving this for y'all, that means 6,000 equals, I did this part in my calculator right here. So if you do, I'll show you how I got 1.01. So if you do 0.04 divided by 4, then you add that 1, you get 1.01. So that's how I got this number, was I did what was inside the parentheses. And then 8 times 4 is 32, so I just kind of carried that over. And then $6,000 equals P times, if you put 1.01 to the power of 32, you get this really long number, okay? So I tried to copy it as best I could. I left off some numbers here. But now that we have 6,000 equals P times 1.37, essentially, with all this long decimal, we know that solving this equation means we can divide this over on the other side. So we divide each side by 1.374940678853. And what you should get for your final answer is $4,363.82. Boom. So, yeah. This is the moment where you guys try the next two examples, and you can take the note that we are continually looking for the accumulated balance. We are not looking for the principal in these last two examples. So just remember that y'all are looking for that principal value. But go ahead and click pause, give it a try, see if you can get it on your own, and then come back. Alright, if you didn't try it on your own, hey, and if you did, I'll share the solution. Okay, here's the solution. Kind of. So this is the work. Here's how I filled it into the formula. Since the APR was 7%, that gets 0.07. Since it's quarterly compounding, we're dividing by 4. 4 times 20 because it's 20 years and quarterly compounding. And then $35,000 is our accumulated balance. Put that all into your calculator. You should get this number, $8,736.04. Alright, go ahead and try that next one. Make sure you can do this on your own. Did you try it? Good. Alright. Here's the work. So this is just plugging everything straight into the formula. Our accumulated balance is going to be 15,000. Oh goodness. I have the wrong symbol. Hello. Let's change this to a number sign and not a percent. There we go. So looking for $15,000, we need to know how much we're going to deposit, so that's our principal. Plugging it right into the formula, 0.05 because that's our rate, 4 because it's quarterly compounding, 10 because it's 10 years. That means 15,000 equals P times, when you plug this in your calculator, you get this number. You divide that guy right on over. And now you have P equals $9,126.20. That brings us to the end of our worksheet. Woohoo! Good job, you guys. I hope that you enjoyed our first lesson together here on our online platform. If you have any questions on anything that we went over today, please leave a comment. Please send me an email. I am happy to answer you in the comment section. I am happy to reply to your emails. I'm happy to schedule a meeting with you. Just let me know if there's anything that you didn't understand from anything on this worksheet. Make sure y'all are working on your homework, and I will talk to you soon. Okay, bye.